Welcome to Security Architecture Podcast, where we help cybersecurity professionals to stay ahead of the curve and ensure they are successful in their cybersecurity journey.
Hi, I'm Evgeny.
Hi, I'm Dimitri.
We have here Nathan from Zscaler. Zscaler is the second time on the show, but we have Nathan here first time. Nathan, can you please introduce yourself and tell about your role?
Yeah, hi guys. Real pleasure to be here. So my name is Nathan Howe, and I wear many hats at Zscaler. By the way, some people might say Zscaler, some people might say Zscaler. I'm Australian. I should technically say Zscaler based upon where I grew up, but it's an American company, so Zscaler. So excuse the inconsistencies there, maybe. So at Zscaler, I actually am currently the director of transformation strategy, which means that I help customers understand the journey from where they are in the so-called old world of IT to where they need to be in the future. How to move from where they once were to the next solution. The goal of that is really to show not only technological steps forward, but also the process of, challenges are faced along the way. And Zscaler has worked with lots of customers on lots of challenges. I also work very heavily with product management and been a solution architect here at Zscaler as well. So I've got my hands in all the different pies, but it's really good to be here and to follow up after my colleague Patrick, and he's in series 1, I believe.
Great intro. And Nathan, what's the name of the offering addressing the remote access by Zscaler?
Yeah, so Zscaler likes to name things with Zs, or Zs, depending on where you're from. And so the Zscaler Private Access is our secure application access solution. It's complementary to our Zscaler Internet Access service that my colleague Patrick Foxhoven covered last time. The Zscaler Private Access is the platform's name. And essentially it does one really important thing, is it provides secure application access to private applications. It's kind of in the name. But the big piece that differentiates that versus everything else out there is that it's not a VPN. It doesn't use any network technologies to be able to connect. It's based upon an application, hence Zscaler Private Access.
We podcast about architecture, and we want to understand the architecture of the ZPA solution, how it's potentially different than the ZIA, the Zscaler Internet Access. What's so unique about it? Why do you guys build it in this way? Do you use private data centers, public data centers? Talk a bit more about demand and what do you do when you need to scale very quickly. So if you want to show slides or whatever, the way you want to present it.
So thank you. I will, and actually I think it's a good point to talk about scale. I know that the name of the company is Zenith to Scale, and we've been built that way to specifically build and drive our business growth based upon what our customers want. And we scale for that, no problem. So let me bring up my screen and show you a little high-level overview of the workflow of Zscaler Private Access, and then we can dive into the scale of the data center infrastructure and how we've managed to deploy during especially the last 6 to 7 months. So very simply on my screen, and it really is meant to be shown as a very simple diagram of connecting users to apps. So the user is at the bottom, applications are in the different data centers or cloud locations. And you'll see these little blue things that are with the Zscaler logo inside them. They're called the Zscaler app connectors. They'll become important in a second when I explain the logic flow. So Zscaler Private Access works very similar to Zscaler Internet Access in that users request an application access, and the client on the client side, on the device, be it a laptop, an iPad, a tablet, or whatever, will request that application, and that application request goes to the Zscaler cloud. That request goes out to the Zscaler cloud, and the policy is then being validated based upon what the customer has configured. So we will get into authentication in a little bit, and access control in a little bit. But the whole idea is that Zscaler Cloud, or the Zero Trust Exchange, is making a decision: is the user authorized for access? If they are, and then we validate to make sure that they have the right rules allowed to them, so can they get to the application request? And if so, this is kind of where the magic happens. So rather than being a situation where we build a tunnel from a device all the way through to a remote data center and the user is then logically on a network, what we're doing here is we're actually establishing an individual tunnel for an individual application. But to build that tunnel up, we're not exposing an inbound path to the destination data center or cloud location. As the animation showed, there's an outbound connection from that little blue connector going to the Zero Trust Exchange, and there's an outbound connection coming from the user as well. So these two sessions are then met together in the middle, and we stitch them together. Now, this is both these tunnels are mutually pinned TLS tunnels. So there's actually a dynamically generated trust between the two tunnels, and they get pinned together and signed together by that individual MTLS certificate. And that is unique for that session. So when the user, for example, then generates another session from another location, each individual application request gets its own individual tunnel. Therefore, and kind of the biggest benefit of the whole scenario is rather than sticking all the traffic through a tunnel, in one tunnel like a VPN would, we're actually doing dynamically generated connectivity paths for each individual application session to wherever that will be and finding the best path to it. As the diagram shows here, there are 3 different connectors and 3 different applications. So those 3 applications have generated individual tunnels for those users, for the user to access those applications. So that's the cool thing about it. We are able to do this dynamic generation, and basically that zero trust exchange becomes the enforcement piece where all the traffic is enforced. Now, this is very similar to our Zscaler Internet Access Cloud, which is globally available in multiple locations. So let me just pause there and see if you guys want to have any deep dive questions on this before we move on.
The zero trust exchange, is this like your own cloud? Do you actually route traffic inside the zero trust exchange? So, for example, here, the employee going to Sydney,
yep.
Does the traffic from Sydney, and if it needs to go to New York, for example, will it from Sydney go to New York inside your cloud, or it will go directly from Sydney to New York on the internet?
So no, we don't have our own backhaul network, so to speak, like that. We leverage the internet. And so all of our data centers are in major peering locations. So we just peer with all of the major Equinixes, the Verizons, the Microsofts, the Azures, the AWSs, Googles, whomever, and we just route across that backplane internet. We're not going to build our own. Think of us as an overlay network on top of the existing network. So we do the security path. We ensure the integrity of the traffic passing from point A to point B, but we overlay that on top of an existing network path. And that has one big benefit for lots of benefits, but one big one is that we don't care about any specific network. And the ultimate end goal for the end user or the application is that they can exist in any location so long as they have an internet path, and then we'll figure out the rest.
So I connected to my destination. Does all the traffic have to go through the Sydney POP from now on?
That's an awesome question. And I really love that one. That's the one I was hoping you were going to ask, Evgeny. So, let's very simply say that if you're looking at this diagram, normally a data center or a cloud provider is going to have a better internet connection, and the user is going to have a less effective internet connection, just the way in which it is. And because of that, the user, we've made the decision to bring that traffic. So to your example, if the Azure connection was in New York and the user was in Sydney, the connection path you see from the little Azure connector would pass across the internet to the Sydney location, because the user needs to connect locally so that we have a minimal latency time for the user to the edge. And then we bring the applications to that same edge where the user is via those tunnels.
So if I need to go to Azure in New York, I'll go to Sydney and then to Azure to New York.
Right, exactly. If you're a user based in Sydney. But if you're a user based in, say, Singapore, you go via Singapore rather than Sydney, or a user based in London, as the diagram shows. And that's why we have that zero trust edge globally, so that it's not necessarily, we're not asking anyone to travel or traverse another country. Stay local, connect local, and then we'll bring the application connection path back to you.
I know in the ZIA, if I remember correctly, you had the options to jump on the Azure cloud, for example, to Microsoft and go there. Is this similar in the ZPA as well?
Yes, so the peering with Microsoft. And yes, but this is less about, on that side of the equation where, for example, the connectors are, that's the customer space. So that connector is inside a resource group inside of AWS, or Azure, or VPC inside of AWS. And it's not something that is governed by us, but it is leveraging the AWS or Azure backplanes or whatever they might be. So to answer your question, yeah, we will peer with Microsoft if we are sending traffic into Azure and we know it's an Azure-based connector, because it's obviously the connection coming from the connector will be based on an IP address egressing from Azure. So we'll know that and we'll be able to send it across our path. The decision we make about establishing that connectivity path is based purely on the idea of what is the most effective path for the user at the time of that session initialization. And we'll do the queries. Like it's not just a blatant connect. We'll also check to see which of the connectors is the best one to be utilized, which of the paths through the Zscaler edges are the best way to connect to. So if the user might be in Sydney, Sydney might be a problem for whatever reason because somebody's cut a link in Telstra in Australia, and maybe we'll have to go through Melbourne instead.
And this happening on the user side.
At Connect. as well as at the application side and the connector side as well. So when we establish those two tunnels, there's a dynamic decision being made of what is the best path at the time of connection. And that's why it's very, let's say, advantageous for us that we do this on a per application basis rather than one tunnel fits all, because then we can negotiate for each individual application depending on where the destination application is and where the user is.
So each application may go once through Sydney, once through London, once through New York, for example.
It all depends on where the user is based, basically. So we'll connect the user to their best POP, the best ingress point to us. And then depending on where the application is, we'll all bring it back to where that user is, yeah.
Oh, okay. But the user is still connected to one location.
Yeah, so the user, if the user, and this is also about the whole idea of speed of light, nobody's going to be able to move from Sydney to London like that, right? So we're going to keep people local. We'll keep the local connectivity within their ecosystem. So if you're in Australia, it'll be Sydney, Melbourne. If you're in Asia Pac, it could be one of many sites within China, Singapore, Japan, and Korea, wherever. Europe, of course, everywhere, in North America, South America, all those different POPs. So we'll connect people locally to those.
On the train, and would I switch to different POP?
As in moving across networks, absolutely. So that's a fantastic thing. So one of the great things is because we're not establishing a permanent tunnel for any of these connections. Sure, if your network drops, and then if your network drops, then your network drops, and you will lose the session anyway because your underlying network has flipped over from a 4G link to a Wi-Fi link. Let's say that causes you to go through different POPs because of peering. We don't care. We'll just figure out that you're coming from this location. Now your source IP address, your location has changed. We'll connect you to what we see as being the most effective Zscaler ingress point. And that may be because you've just changed countries, which is quite common in Europe, of course, as you cross borders. But that should be completely untransparent to the user. The user should not know that the connection to the Zscaler environment's gone down. They may see the internet connection's gone down, but as soon as there's an underlying internet connection for us, we'll establish the users right away to wherever they need to go without forcing them to reauth, because we're respecting the single sign-on user being on the device, having a trust of that authentication. Now, if we go down that path, if for whatever reason the authentication is expired, that's another conversation, which I'm sure we'll touch on a little bit. But yeah, if you're on a train, absolutely, and you happen to just jump hops because of your network path, we will find the next best path for you.
So this traffic traverses the internet. How is it encrypted? Can I use my own certificates, keys?
So by default, we generate so one thing I actually will go come on and say, we're a multi-tenanted cloud, much like we have Zscaler Internet Access. So when we generate a tenant for a customer, one of the key things there is that we generate them a PKI for them. Now it's by default, just because not everybody wants to bring their own encryption. But what that means is that we generate a root certificate in the cloud for that customer. And then from there, there are intermediate certificates generated on the connector side and the client connector side down at the bottom, the little app forwarding app that we have. And those certificates are enrolled once the user at the bottom and the app connector at the top are enrolled in the service. And then for each individual session that is created, there's another intermediate certificate built off that with a unique ID for that session, which then we say, okay, hey, intermediate certificate on the app connector and hey, intermediate certificate on the client connector at the bottom. This is the individual session ID. Create a new set of trust for this session, establish this trust. You both have the same MTLS and you have the same ID, connect in the middle in the cloud and pass the traffic through. That's default operation. But of course you can bring your own encryption. There's no reason why you shouldn't. And of course, the question comes into play, do I want to have a trust back to my internal enterprise CA? Why not? You can absolutely do that. If you want to leverage that, and then for whatever reason, you want to revoke your certs, then everything stops working because it's your cert. Mm-hmm. It's just that we generate individual certs for each customer because a lot of our customers don't have that strength of knowledge in PKI.
And even more from what you're saying is you actually generating one-time certificate for every single connectivity session.
Exactly.
I mean, once the session is off, after some timeout, it's been destroyed and that's it.
And the idea is two things. One is a certificate is for an individual trust, for an individual session, which is key. But the second point is that the token that we use to generate that, so we call it a Microtunnel ID, but it's our unique ID for the session. We generate that so we can also use that to steer the traffic. So when we see that any session coming from a connector, any session coming from a user with that Microtunnel ID, we know that's unique and we know how to connect those two together. So we don't want to have repetition there. We don't want to have those things. So it actually works in double effect. It also impacts the connectivity path, but also the encryption of that connectivity path. So of course, one time is best.
How do you license the product?
So, I mean, ideally, we want to make sure we can provide as much as possible to our customers, but that comes down to our customer's decision. And so very similar to or actually exactly like our internet access products, we license on a per user basis, which is annual. So it's per user per month, and that's annualized. And so that's not based upon anything complex like concurrency or number of devices. It's the idea of you're one user, you need to get access to applications from your home laptop, your tablet, your phone, and do it all securely. So the whole idea is one user. So it's completely licensed on users. Now, there are different scales, and we call them editions, that depending on what the customer wants to buy, they can buy a very basic version of the solution, or they can buy a very micro-segmented solution, either way, and we can help them out with either one of those. It comes down to the customer's choice. But to your point, we don't need to have a customer utilizing the Zscaler Internet Access Platform in order to have ZPA. They can get Zscaler Private Access by themselves, use it for just that service. And actually, that's something we do see quite a lot. As if you think about this for a second, and you step back, Zscaler Private Access, whilst it's really good at providing remote access, as you see in the diagram, if you can think about it for a second and think, well, hold on, these users at the bottom are never on the network. So then where else can I use this scenario? And there's a lot of other scenarios this plays out to, like mergers and acquisitions, where you want to buy a company or merge with another company, but you don't want to give them access to your internet services. They have their own, but you need to give them access to your internal services. So rather than going away and doubling up MPLS, firewalls, double NATs, and so forth, you put the client on the device, and then basically you would enable policy and say, okay, I want users from this newly acquired company to get access to individual applications. You're doing a user to application access path, and it's just the private so-called application and not the internet path. It really comes down to the way in which our customers want to consume it.
You can expose subset of applications to specific users or groups.
Yeah, well, that's the whole idea. It's a zero trust model, and that we build from the ground up nothing. Nobody's allowed any access until you validate who you are. Only after authentication, then the policy defines whether you're allowed access to which application. And that's up to the customer to define what is the best solution. Is it going to be a star.company.com and allow everything? Or is it going to be a specific application on port 80? It really comes down to the individual choice.
So we're talking a lot about identity. And you, as you mentioned, you need to identify who you are first. Do you do it before people connect? Do you connect with all the major single sign-on platform? Can you elaborate a bit more about this connectivity and connection?
Yeah, that's a good question. I think the key thing here is that with everything at Zscaler, we won't do anything until we validate the user. That's critical. We need to understand who we're applying policy to. And that's obviously the model of zero trust and all the other fancy buzzwords that are out there. You need to validate who the user is, and more so than just the user and the device. Because I think the user and the device context play into each other. To come back to the point from before, why should my tablet have as much access as my work and my company's computer to the environment I'm getting access to? So I can set different controls based upon the trust of the end device, along with authentication to validate that access path. So identity of the user comes down to really, as you rightly point out, Evgeny, is the idea of validating against industry standard identity provider. So we consume SAML 2.0 as the valid authorization path and authentication path. And we'll consume not just the valid, so basically when a user wants to access our service, we will redirect them to a customer's identity provider. Now that can be completely set up at the back end with single sign-on. And then of course, if the customer would like to utilize multi-factor authentication, YubiKeys, any of the physical tokens they'd like to leverage, that's all on the identity provider side. We are just consuming the result of that authentication. And once we have the consumption in our solution, we're able to say, okay, the user is signed in, they will have an authenticated SAML certificate, plus we have their SAML assertion with all the attributes associated with that user. And we utilize those attributes to define policy, to access policy based upon what was configured in policy by the customer themselves. So yeah, we completely integrate with any IDP. One of the big benefits of those things now is with like the ones like Azure AD or Okta, is that we're able to do SCIM as well. So that if for whatever reason your your user base changes. You want to change a user's permissions. And that will be reflected in the SCIM policy that gets updated to the user and to the Zscaler private access engine so that we can change the access rights based upon your SCIM policy.
Let's assume that there is a user that tries to access a resource that he's not supposed to access. Is there a way to alert about it, let know to the IT team, to the security team, to the SOC, something like that happen?
So we do have pretty substantial reporting within the Zscaler Private Access portal, but what we tend to encourage our customers to do is rather than leverage us as a reporting mechanism, you should send those logs in live to your actual SOC and let your SOC alert on those from one central location rather than having different systems or ZPA, ZIA, other solutions alerting. So we have a log streaming service that we send in live logs in real time directly into our customer's SIEM or SOC environment. And we do that in a pretty standard way. It's basically syslog, depending on the formatting of how the customer wants to consume it. And that's basically what's really cool about that is that if you think about this, you see the little blue connector on the screen. That's a little virtual machine running somewhere in a customer's ecosystem. And we can leverage that as the point to send logs through. So we'll say, okay, you have a SIEM somewhere in your data center or somewhere in your SOC, put a connector next to it, and we'll just, and by configuration, send logs through there. So then it streams logs directly into your SOC, and you get live alerting there. Of course, we'll do reporting in our policy engine, but it makes more sense from an overall security monitoring point of view to have one centralized location for reporting. Happy to show that to you if you'd like.
Yeah, I would be happy to see that. That's very interesting.
Cool. So let me just stop sharing, and I'll open up the window because I have it up in advance of you saying yes. So long as my session didn't time out. Let's just see. No, it's still going. So this is the Zscaler Private Access dashboard. And this is where we give an overview of what access is going on. Now, this is just an example from my home lab, so there's not exactly a lot of traffic going through here. But you'll start to get an overview of what the sort of services are and what we can provide from a connectivity point of view. So you'll see some pretty simple things like applications accessed, top by bandwidth, and so forth. But then things like this, you get to see error messages, and you also get to see top policy blocks. So if you were blocking a user, you would actually see that there's a block being enabled here. It's a simple little dashboard to show that. And I'll give you a couple of other examples of visual information we provide to our customers. For example, you get to see users. And so this is a user policy dashboard. And you can see right away that my account is the one being blocked. So if I wanted to, I could click on this and go directly into the individual logs, showing which ones that I've caused or my account has generated to cause a block. So yeah, in the last 1 hour, I generated a bit of traffic. So you can see there's some policy blocks here from my user. So I now have a filter in place on that user account. And I can see here that this user was blocked because the application is not reachable. So the application I was trying to access, for example, if I was trying to scan the internal network, I couldn't and it was not reachable, then I would actually be alerted here because the application is not part of that network space or application space that is defined in policy. What's good, and it's probably worthwhile just taking the opportunity to walk you through this diagnostic log, is to show what's captured in an access path. And I'll use an actual valid access path to show the details. So besides the date and time and timestamps and so forth, you'll also see the total number of bytes or kilobytes or megabytes per session. This is actually really interesting from an individual session. If you're looking at each individual log, not the entirety of a VPN tunnel. We're looking at each session that is generating this one's 4.7 kilobytes. Whereas I might have when my computer decides to back up to my NAS, it might be a terabyte. Who knows? So you'll see those individual logs there. You'll also observe that we have some really cool things like these unique IDs, these strings here. These strings are specific for each of our environments to help in the correlation back at the SOC. So we can actually say this is the connection ID or the policy ID that we use to correlate against the backend. By the way, I mentioned before that this is the connection ID. This is what we utilize to generate the individual certificates as well. So that's the unique ID per session. You'll see policy. You can define different policies, and I'll show you the policy in a second. And policy ID. We also have a re-authentication policy. So ideally, you don't want someone to have permanent access to your backend ecosystem. You want to kind of reforce them to revalidate their authentication however many times you need per month, per year, whatever. So we have a timeout policy allowing customers to be able to then define, I want users to re-authenticate and revalidate that SAML certificate every 7 days or every time they access a certain application. It really is up to the end customer to define that.
Yeah, definitely very detailed.
Yeah. And you'll get everything else for application, the Zscaler part of the infrastructure, the customer part of the infrastructure, and so forth. And it's meant to be that it's showing information that is valid towards that connection. Now, as I'm living in Europe, I should call out one thing. In terms of GDPR, there's one piece of information here that might be flagged, and that is the username. Now, the username for us is actually what the customer sends us. It's actually the UPN. So it's the universal principal name from my Active Directory environment that I'm sending through. We have customers that will send us a random string, and that random string then ties back into an ID within Active Directory that we have no idea about. So it's really up to the end customer to define that. I just happen to be very open with my name is Nate. There you go. So, but yeah, that's the detail ecosystem. Yeah.
Let's describe a little bit the user access options, right? As you know, most of the people today in the world, they're using their browser for work and for privately browsing the internet.
Yeah.
So everything happens today through the browser, right? I mean, accounting, development. So how does your solution work? Do you have like a client-based approach, or you also support a clientless approach? So
we have both. And it's worthwhile me showing you the client just so you can see it as an example, and then I'll talk to it and how it works versus the clientless version. So here, this is the client. It runs the different parts. We have Zscaler private access, the internet access. We also have a platform called Digital Experience, and we have information about logs and so forth that are in there. That's it. The customer ultimately, the end user should never see this. It should be just running in the background. And all it's doing is forwarding traffic. And that forwarding of traffic is defined by the policy that the customer has. And so that you can say what is internal, what is external. And if it's something that's internal, considered private, it would go via private access, the Zscaler private access, this icon here. If it was going via the internet, it'd go here and so forth. Now, the reason why we have the client is that Zscaler Cloud is in the cloud and it's on the internet, and we need to get traffic from the users wherever they are to the cloud, and we need to forward traffic. So Zscaler Client Connector, you see here, is actually forwarding traffic and nothing, that's it, nothing else. It forwards traffic to the cloud. Policy enforcement is within the cloud, the Zscaler Zero Trust Exchange. There's nothing, no magic happening on the device. It's just forwarding traffic. We don't do any policy enforcement locally. We do some very small checks of trust on the device, like is it a trusted device based upon certificate validation, hard drive encryption, all these sort of device posture assessments. That's purely just to make sure the device is valid in terms of policy. All policies done on the customer side, on the cloud side. Now, the key thing about the client is that it's forwarding, and because it's forwarding from the operating system, we can do all TCP or UDP, which is a big benefit, of course, when you have more than just a browser. And I understand that's, if you want to do an SSH session or an SQL transfer, or any of these things, you're going to need a full client because it captures all ports or protocols. And that's basically the cool thing about it. The other really important part is that anything that goes into the private access cloud is completely hidden at the back end. So if you remember the diagram from the beginning, there's an outbound connection coming from where the connectors are. Those connectors are not exposed to the internet. There is no inbound connection to where those applications live. And so we can actually turn entire data centers or ecosystems dark and not expose those applications to an open network. And by doing that, we remove, we're basically saying we do the steering via private access via the Zscaler client connector here. And that's great because we can forward traffic to our cloud and decide on policy. Now, I'll stop sharing and go into and talk to the browser access, because browser access is in a browser. And that has a couple of advantages and a couple of disadvantages. The biggest advantage, disadvantage, depending on how you look at it, and you pointed it out, Dimitri, is so many things are now within a browser. So if you can transmit application in HTML, HTML5 in a browser, cool, we can work with it. It's in a browser. But if it's anything like a fat client SSH or anything else, we will not install on a customer's device some sort of virtualized JavaScript NIC that routes traffic. We'll never do that. We don't want to do that. We really specifically call our solution browser access. Thus, anything that functions within a browser goes within the browser. And the one difference, as I mentioned before, is that we're forwarding traffic through the Zscaler client connector. But with the browser access, we have to get traffic from the user's device, and we don't have that client running on the device to do that. So we have to expose some sort of path to that. And that's basically saying we have a domain name the customer will expose. It'd be just whatever it might be. But rather than that pointing back to an IP address on the customer's ecosystem, it actually is just CNAMEd to the Zscaler infrastructure. So we're saying when you try and access this application, oh, that's a Zscaler solution, go to Zscaler. We'll know based upon the inbound connectivity path that that's something going for customer A, and we'll redirect the user off to authenticate against the IDP. And that's the basic functionality. So it really is browser or client. Yeah.
You mentioned different ports and protocols. So what do you support? Can you do printing? Can you do VoIP? Can you do file sharing? Can you do password changes?
So I laugh at printing because one of our biggest customers during the pandemic rolled out to ZPA to all of their users. And we ended up seeing like 1 million print requests an hour from all the clients to internal print services. And who's going into the office to get a print out anymore anyway? Mm-hmm. So absolutely, yes, printing works. That's not a problem. But then the question then comes in, and before I answer specifically around the others, is with everyone working from home today, is it really worthwhile having a print server and inside the company being active? That's a different conversation. But so yeah, anything TCP, anything UDP that is client initiated going through the tunnel, not server initiated. And because if you remember, these devices are not connected to the network where the applications are. And because of that, there's no way for a server to connect back to these applications. So again, what really needs to be done there, if you talk about things like, like a good example would be like SCCM or any sort of patch modules. Today, I would say rather than pushing patches across a Zscaler private access tunnel to all of your clients, maybe you have your clients go and get the latest patches from an internet-based service as a workaround. But SCCM also works in terms of client calling out and pulling as well. It doesn't need to get pushed to. It's just a configuration change in that regards. File shares, that's standard, not a problem. Authentication of passwords, yeah, that's easy. That's quite normal.
What about VoIP?
So I specifically left VoIP to last, and there's an intentional reason for that. Without talking about Zscaler or any other forwarding technology, it's just not the most effective thing to encapsulate a voice packet or a video packet for that matter in a tunnel and sending it via a dedicated gateway. It's just not the most effective for the services. I think we see that now with we're on Zoom right now, but there are other platforms that are all internet based. Now that's the more effective way. So we would actually say, yeah, you could send traffic via tunnels, and some customers try, but if you think about it, you're encapsulating a UDP packet that's going to route through a whole bunch of internal infrastructure. It's not the most effective way of doing it. So we always recommend, from a pure effectiveness, stick an edge service, put an edge service on your data center edge or your cloud edge, if you're still using an old legacy Jabber or Skype service, and do that at the edge of your ecosystem rather than have everyone go internal. It just is more logical.
So Nathan, we spoke before about roaming. What happened if a user worked on a very slow network?
That's a common conversation point because, well, I mean, my parents live in Australia and they don't have the fastest internet connection in Australia either. And they use my Zscaler services, my lab, to help them get access to things as well. So we respect the local network. Let's be very clear. So because we're not setting up a permanent tunnel, we're not putting a substantial amount of overlay on top of the network to force all that traffic, which then has to be managed by that slow link. We are doing individual sessions. Now, if a link is slow, then we are stuck with the speed of the link. We're never going to improve the speed of light, but we'll function absolutely over that link. It's just a matter of having patience for it to load.
Do you guys use SSL or do you use any other protocols?
Yeah, so we forward with TLS. So TLS 1.2 is our forwarding mechanism. We also plan to release this year DTLS as well to improve that. It's not always an improvement. It depends on the scenario, what applications are being used, but we plan to support both of those things.
So in this case, if I were doing something and I get disconnected and I connect back, would I resume my session?
No, the session's gone, right? So, I mean, the link's gone. If the link's gone and we've lost our connectivity, we're not holding state. And you bring up the point when you ask about TLS, because no, we're not holding open any state. We're not looking into packets. We're purely providing a secure path. And as soon as that session goes down, that session's gone.
Let's talk about reporting and user behavior. And the reason why we have this topic is because we all work from home. And our footprint pretty much changed completely right now.
Yeah.
So for people to understand from where you connect, what are you doing? We mentioned about going on a train or people don't change locations or speed of light. How would Zscaler ZPA will understand, oh, Evgeny just connected from Toronto, and in 5 minutes, he just connected from Australia. Something fishy going on. Maybe I need to stop Evgeny. Maybe I need to alert Evgeny. So tell me about the UBF functionality and the reporting part.
Right. And I think I kind of touched on this a bit earlier, but it's worthwhile diving into more of it. So whilst we are able to provide more insight around where the user is connecting from, and we can see based upon their source IP address where they're coming from, there may be reasons, pardon me, that they will switch. Like, for example, if they switch between 4G in one country to another, that may be seen as a bad thing, but in actual fact, it's just someone roaming. So one of the things we've been working on is not actually on our side, but more with our partnership with Microsoft around this, is leveraging Microsoft for conditional access to do the validation prior to utilizing Zscaler Private Access. So that risk assessment that conditional access provides allows us to then consume that result from Microsoft as a SAML attribute and then put that in policy for configuration. So we don't actually validate geolocation of users. And to be honest with you, whilst we certainly record their location when they like the egress IP address, there's no real reason, and we're a cloud service, we don't believe in source IP as being a valid security token. There are different values to that. And so that's where we do validation of the client side and to do additional checks. So one of the things we also do is, like with the likes of CrowdStrike, is we do a device validation as well. So we'll do actual checks through is CrowdStrike running, what's the current status, can we do some API signaling to each other to be able to provide information about the trust of the initial connection. However, to your point, the geo thing is something that a lot of our customers have requested. So that's why we work with Microsoft on that. But there may be a reason for us to do it in the future. To be honest with you, though, now everyone's at home, it's less and less likely because you're not going to see people moving that much.
Yeah, please.
No, however, just going to say, we'll see it in the logs. And that's where I mentioned before, setting it to a SOC to make an informed decision about multiple values, not just upon the connection source. It helps to be able to provide better insight.
Right now, you will not stop or not. Basically, you don't have a risk approach. You don't say Evgeny is a more risky user. Evgeny just moved 8 terabytes of data and he never moved more than 2 gigabytes of data, for example.
Yeah, so that part of the orchestration piece is what we're actually working with with our APIs and our API partners. So we don't want to be making those decisions based solely upon our platform. We should be making a decision based upon insight from the file share server, should it be the conditional access. And that's where we want to work. And we're doing this later this year, is integrating with our orchestration partners to be able to say, okay, if these things, values and so forth match, then place the policy block in place on Zscaler to do the block. Because ultimately, if you think about what Zscaler Private Access is, and it is a very cool platform, it's just steering the traffic based upon the trust that has been established. We go from zero, we build trust, and then we steer that traffic. Now, there's more insight that needs to be made there and had there, and which we can provide which we can pull in from our partners. But the orchestration should be done by a SOC rather than just one individual platform.
We're kind of done with the official questions and the topics.
Cool.
So we're going to move to open conversation. I have one question that was kind of back in my mind that I wanted to ask.
Yeah.
What happened if a customer has Zscaler ZPA, they work from home, but they use somebody else for URL filtering? So they don't use ZIA, they use somebody else for. Why happened? How will this work?
I mean, like, hey, I'm a security guy. I play with lots of things. I have Pi-hole here at home. I used to use OpenDNS before these sort of things. So like, yeah, you can absolutely do all these things. So the only thing is, because we're an internet service, if you do have a URL filter in place, you would need to bypass the Zscaler Private Access destination pieces, because we are sending traffic to the internet on TLS port 443. So it will be seen as an egress connection from the client going out to a destination server on 443. So there would need to be a whitelist put in place for the Zscaler Private Access services.
So right now, when the client installed on my device, it's sending all my traffic to the closest POP of Zscaler.
Only the private application traffic.
Okay. So if I have my private application routed there, it will go there. But if I go to Facebook, it will not go there.
No, exactly.
So why do I need to bypass Facebook?
No, not bypassing Facebook. You'd bypass the Zscaler Private Access application.
Okay.
So it depends on your URL filter, of course, right? So if you're doing very restrictive protection, just to be sure ZPA works, you need to bypass the ZPA URLs.
Gotcha, because you're going to have a race condition who takes first the routing.
Right, exactly. And so that's where, in that scenario, you want to make sure ZPA is bypassed in that scenario.
In case of ZIA, as in this case, would the traffic go separate to ZIA and separate to ZPA?
Correct.
And they will have their own paths and their own channels?
Right. Yep, exactly. That's exactly how it works. So, and actually the priority would be you request a solution, an application, The Zscaler client connector will say, okay, this is something in policy that is either for private application access first, then internet access, and then if not, local network. And so that's the priority stack. So we will say, does it hit the ZPA? Because ZPA is more specific. Internet access is everything, right? Basically, and then you have a local RFC 1918. So it'll be ZPA, ZIA, local network.
Last technical question. Do you have a story of a problem you guys had during ZPA implementation that you guys didn't know what to do, or was completely unexpected, and you found a way to overcome this? Or maybe something you see all the time while you...
Yeah, actually, I've got a great one. And it's a great example of internal, external mindsets. So recently we did a deployment with a very large company in Germany. And when all the clients were now off the network and using Zscaler private access, they still ran a local client, a piece of software on the device for internal CDN, for basically broadcasting messages from the boss. From the CEO would do a webinar, it'd be broadcast to everyone's device. But it was peer-to-peer. And what happened is that basically the peer-to-peer signaling on this piece of software checked to see if it can reach a server. If it can reach a server, it's on the internal network. But all these devices were at home, hundreds of thousands of devices were at home. But they could still see the internal server because ZPA was providing the path. So when they did this webinar, we went, why is this massive increase in video traffic smashing our European and our worldwide Zscaler infrastructure all for this one customer? And it was because the client didn't turn itself off because its configuration was, I'm inside the network because I can see this internal solution. And that's the advantage of Zscaler private access. The device thinks it's inside the network, even though it's not. It's just being completely isolated from it. So we had to do because we didn't know what was generating this. We had to kind of work with the customer and say, what's going on? Why is there so much UDP broadcast and multicast being sent out? And let's figure this out. And we worked our way back and figured out that actually because the device thought it was in the local network.
You didn't need to configure this particular application to work. It just worked by itself.
So when you define the policy in Zscaler, the Zscaler private access, you can either be very, very, very specific for this user to get to this application, and there's most of the cases with our customers, they start very broadly because they don't generally have an inventory of all their applications. So what they'll say is they'll put a whole collection of wildcards like star.company.com, star.company.net inside and say, this is the policy. Anything going to those domains on any port is private. And more than likely, you're going to find some things that are split domains. You're going to find some really funky DNS. You're going to find some, that's another great example is just to give you an example, the connector that runs inside the customer environment. One customer built a solution, the standard image for connector. They built it with their support team, and the support team was in Germany. And that image was then copied and moved all the way around the world. And that image included local DNS for the German data center. But when that connector image was stood up in Mexico, it tried to reach out to the German DNS. So of course, because that's the configuration. So there's little things like that pop up that are always like, our network still has the customer networks still have a lot of legacy internally, and a lot of misconfigurations that are not always going to be overridden. So it's a progressive thing. But the advantage of the platform is that we give the customer the visibility. So they can see when they use that wildcard and then wildcard.company.com, they can see everything internally. And then they can see what traffic's flowing. Well, not everything internally. They can see everything that's being requested that's inside that space. And then we give them a report saying, these are your applications that your users are accessing. And they can go and figure out, that's SAP, that's a file share, that's this. I'm not going to tell a customer what each application is. They have to do it themselves.
Nathan, thank you very much. It was a pleasure. Anything from you?
No, thank you guys for having me. Hopefully I covered the topics.
Yes, we're going to post links to demos, to POCs, and to your profile as well. Cool. And we'll let you know when we're going to share the episode. Thank you very much.
Fantastic. Evgeny, it was great. Thank you so much.
Thank you.
Please remember to subscribe to our podcast and join us for our next episode.